So welcome. So now talk about basic attenuation mechanisms. So that means types of losses in optical fiber. So fiber loss, also called a fiber optic attenuation or attenuation loss, refers to the loss of signal between input and output. So losses can be introduced by various means such as intrinsic material absorption, scattering, bending, connector loss, and more. So losses can be divided into intrinsic and extrinsic losses types of depending on whether the losses caused by the intrinsic fiber characteristics or operating conditions. So intrinsic optical fiber losses consist of absorption loss, dispersion loss, and scattering loss caused by the structural defects or quality of the optical fiber core itself. So extrinsic optical fiber losses originate from the spelling loss, connector loss, and bending loss. And so first we discuss intrinsic absorption. So intrinsic fiber losses or cable attenuations is a measure of the optical power of the fiber itself due to the light absorption of the fiber material, scattering, and dispersion. So it is the measured in a decibel per kilometer within the relations A decibel equal to 10 log P in divided by P out. So where P in P out is the optical power going into and coming out of the fiber. Intrinsic losses in the fiber itself are relatively small. So modern optical fiber are designed to have low intrinsic losses to ensure efficient signal transmissions is over long distances. So that material absorption as light in the traditional optical fiber is guided by a solid material. So there are losses due to the absorptions as light propagates through the fiber. The most common fibers are manufactured using fused silicon and are optimized for transmissions for 1300 nanometer to 1550 nanometer. At wavelengths less than 2000 nanometer, multi-phonon interactions in fused silica gas has significant absorption. So alternative fluoride glasses such as ZF4 and ANF3 are used in the manufacturing mid-IR optical fiber primarily because they exhibit lower loss at longer wavelengths. So contaminates in the fiber like water molecules contribute to absorption loss. Water molecules trapped in the glass of the optical fiber can be absorbs the light absorbs the light around the 1300 nanometer and 2.94 micrometer. The attenuations undesirable as it affects telecom signals and lasers operating in the same region. The scattering is the process by which some or all of the optical power is transferred into the another mode. It is occurs when the light encounters a change in the refractive index of the medium. So this can be caused by the irregularities in the refractive index of the fiber, impurities, particulates or bubbles, or intrinsic caused in the fluctuations in the glass density, fiber axis directions, composition, geometry, or phase state. So there are two main types: Rayleigh scattering and Mie scattering. The Rayleigh scattering contributes up to 1000 90% of total light attenuation is in optical fibers. It is in a form of elastic scattering that occurs when light interacts with particles that are much smaller than the wavelength of the incident light. And Mie scattering is a type of scattering that occurs when the light interacts with particles that are comparable in size to the wavelength of the incident light, such as inhomogeneities in the fiber core or cladding or external contaminants. Thank you. Next class.